Good morning. Welcome to GELION PLC Corporate Developments and Progress Investor Presentation. Throughout the recorded meeting, investors will be in listen-only mode. Questions are encouraged and can be submitted any time by the Q&A tab situated on the right-hand corner of your screen. Just simply type your question and press send. The company may not be in a position to answer every question received during the meeting itself. However, the company can review all questions submitted today and publish responses where it's appropriate to do so. Before we begin, we'd like to submit the following poll. And now let's hand you over to John Wood, CEO. Good morning, John.
Morning, Paul. Hey, great for this opportunity to update you all today. I'm going to give a special sort of focused presentation for you about some progress we've been making, some exciting developments, particularly in the area of our GELION sulfur battery technologies. Now, there'll be a few takeaways from this presentation. The first one is that we've got some remarkable progress being made on sulfur. It's been quite a progression. We've got ourselves into an important position. We're going to be sharing some breakthrough results. Secondly, those results have been recognised externally, commercially. So we're going to talk about some of our activities towards collaboration with corporate strategics. Thirdly, we're going to talk about the fact that our integration business is bringing on revenue and margin for us now. So early first revenue and margin, we'll discuss that in the course of this presentation, one of the takeaways as well. Still incubating our recycling and our zinc businesses. And today, though, we're going to focus on those particular highlights. Now, I have a presentation team with me today from Sydney, Australia. I'm sitting in London. We have our CFO, Amit Gupta. We have our CTO, Lewis Adriansons, and we have our President of UK and Europe sitting with me in the office, Adrian Amig, and we're also very lucky today to have with us one of our non-executive directors, Mr. Graham Cooley, who I think everybody knows has a lot of experience in taking innovation through the cycles to commercialisation. So across to Amit, if you can give your background.
Good morning, everyone. My name is Amit Gupta. I'm the CFO of GELION. Been with GELION for almost 4 years now. Fantastic. We've made great progress this particular year, and in FY25 is a transformative year for us, given we are going to start generating revenue and margins, and the sulfur technology development is making really, really good progress. Great to be presenting our results and some forecast numbers to you today as well.
Thank you, Louis.
Yeah, thanks, John. So my name is Louis Adriansons. I'm CTO at GELION. My background before joining GELION was in battery manufacture. I worked for Panasonic at the Tesla Gigafactory. And Panasonic's job there was to make the actual battery cells, which were sent across to the other side of the factory where Tesla put them into modules. Now, the position I had was supervisor of chemistry, and that position looked over the chemistry aspects of a system that produced, or a factory that produced 5.5 million batteries every day. And so my goal here at GELION for the last 1.5 years has been to take the technology we're going to show you today and bring it to that same eye-watering scale of production.
Adrian.
Good morning. My name is Adrian Amig. I'm the president of GELION UK and Europe. I also have a background in battery science. I've worked on sulfur batteries for over 10 years now, and I joined the company by way of acquisition when GELION acquired Oxford Limited 2 years ago. And I am now supporting John in the growth of the company in Europe.
And Graham, we'll give you your background as well.
Yeah, thank you. So I'm Graham Cooley, delighted to be an investor in GELION and also a non-exec director of the company. You're going to see some fantastic results today. I have a background in energy storage and pleased to say I've been able to achieve 2 unicorn companies in the area of energy storage. So really delighted to be here.
I'm John Wood. I'm the CEO. Now, I've only had 1 unicorn in my history, but 4 companies that I've built and have gone on to be acquired at high multiples. I joined GELION quite simply. I had started to invest in sustainability, and I was enticed to join GELION by the opportunity to work with the remarkable Professor Thomas Maschmeyer. So Thomas is our founder from the University of Sydney, regarded as one of the top 15 chemists on the planet, and an absolute treasure in what he brings to our company. It has been everything I've been seeking in working with and alongside Thomas. He brings along some of the best people and capabilities, and we'll talk a little bit about that in terms of the extension to Max Planck that came from an introduction by Thomas a little bit later in this presentation. So our agenda, I'll take you through the proposition, our business model and partnerships. I'll talk about our product technology. Adrian will introduce the IP and the technology, and actually then pass to Louis, who's going to give you some access to some of these test results and explain those test results to you. Amit will then come in to talk about the financial snapshot and the capital raise outcome. I'll then talk about the outlook and where we're going from here. All right, so why sulfur and why are we so excited about this all? The diagram you see in front of you represents the growth in the battery industry. This is now a maturing industry. This is an industry growing extremely fastly, but there's a lot of demand on that industry. We basically need to move from that bottom left corner where you see that 3,000 gigawatt hours up to a scale of the order of 240,000 gigawatt hours. Now, the primary determinant in pulling that off is strategic materials. And of course, that's becoming more and more topical today with countries looking to secure their independence in their supply chains. This diagram shows you the current status today around the world. It's not pointed anywhere, but China is doing a big job bringing in new renewable technologies. But on the other hand, China is dominating the supply chain for those new renewable technologies as well. So in order to get the big prize and move forward in the energy transition, what we need to do is to make battery materials a bit more agnostic and more available, and to grow them to the scale that we need. Sulfur, quite simply, is a major resource to be able to do that. If you look at the circles, there's actually 3 circles on the right-hand side. One is so tiny it looks like a dot. What you're looking at is the abundance of materials and the availability of materials. So you can see that sulfur is simply huge. So, all right, we've got this abundant, low-cost material. So what's the challenge? What are we looking to do? People have been working towards commercializing sulfur battery technologies for some time. It's been a gnarly challenge to bring it along. Sulfur has huge advantages. It's lightweight, very lightweight. It's basically the lightest battery. You could do a lithium-air battery, but then you're dealing with oxygen as a gas instead of using a solid. Very, very difficult. So in practical terms, it's probably the lightest weight battery. It's low cost, it's abundant, and it's environmentally friendly. However, historically, sulfur has suffered a couple of challenges. The first one of those is in power. How quick can I charge and how quick can I discharge the cell? It has not been a good technology for power. And secondly, it's had a challenge on cycle life. How long can I cycle for? So what we're doing with our most recent breakthroughs and relationships and collaborations is we're no longer trying to be the best lithium sulfur company. We're actually trying to move sulfur up into the top quadrant here in cycle life and in power. In other words, our ambitious goal is to move sulfur to where we can compete with LFP, the incumbent in ESS, and where we can compete with lithium manganese nickel cobalt in high-end transportation. To do that, we need all of the elements. We need the lightweight, the low cost, the environmentally friendly, the high power, and to have a cell that cycles for a long time. So how do we put this together? I've been CEO now for 2.5 years, and in that time, GELION has moved very, very quickly to assemble a compelling position in sulfur. We're very fortunate to have been able to build on the original IP that was contributed by Professor Maschmeyer as part of the IPO. But quickly on top of that, we acquired the Oxis portfolio of lithium sulfur technologies from Johnson Matthey. And of course, Oxis had put in, I believe, in the order of £100 million, where you consider the capital and the government grants over the course of 10 years, to develop a fundamental platform, the basis of IP, some 220 patents that we acquired. Now, we picked that technology foundation up with enhanced our own IP. We've developed our facilities and capabilities, really built a strong team. The people that are joining me on this call today and the rest of my leadership team in July are first class. So we have a great team, great facilities, great IP. And then we needed that last piece that you see in the bottom left corner of that square. That's the deep tech collaboration partnership that we put in place with Max Planck. That is really important to us because that is delivering to us the power and cycle life that we have been seeking. So all the applications that you see down there in the bottom right corner, ESS, grid, and remote power and transportation. They need a well-rounded cell. You need to have all of the capabilities. Max Planck had been doing remarkable materials development, one of the most amazing materials development centers on the planet, under the remarkable guidance of Professor Marcus Antonietti. And they had breakthrough results with sulfur, applying very new technology approach. And it's shown in their testing that they could get more than 1,000 cycles under strenuous conditions, and that they could charge and discharge it up to 6 minutes. Now, in the sulfur world, that's remarkable. So that's a significant extension in cycle life. It's a significant extension in power capabilities. We're blessed to have an introduction from our founder, Professor Thomas Maschmeyer, to Professor Antonietti, and then we got to know the team over there and their capabilities. We put in place a 3-year collaboration agreement. Having all the elements now, having a sound IP portfolio, all of our patents and all the base technology foundation. We also acquired Oxlid, which brought Adrian as we moved along in a team in the UK. Having set that foundation, what we're setting about now is to put in place strategic partnerships as the third element in our plan. Now, looking at this map, you can see up in the UK and Europe, we've got strong relationships in the UK with Faraday, the UK government's battery initiative. We've got now a strong relationship with Max Planck. Down in Australia, the relationship's working with the Australian government. A bit of a call out to ARENA, amazing support for Australian industry from ARENA in Australia. And we're reaching into the US. But the fact is that I think it's 95% of the world's batteries are made in 4 countries. And you can see those countries there. That's Japan, South Korea, and China. Well, they're actually made in those 3 with aspirations that India will become a major producer alongside of the other 4. So that's where the world's batteries are being made today. Gelion's approach is simple. We don't want to build a gigafactory. We don't want to go and fight the incumbency. What we want to do is to find our way into the supply chain and integrate into the supply chain. So what you will see us progress to do now is to build on this progression, have the best technology, build on extraordinary material science capabilities. So the 3-year program with Max Planck building on work they've done. They take those materials and convert those materials into the capability to scale them up for production. There's where our Professor Thomas Maschmeyer's particular skills, individual skills, lie most deeply in this area and in catalytics. So we're building now on these capabilities and doing it off a base of excellence supported by our IP and our patents. Okay, now what do we have to do next? What we have to do now is find our way into the supply chain. And that's to adapt our materials into the cell manufacturing processes. We don't want to build a gigafactory. That takes billions of dollars. It takes years, and people have already done it. So what we aim to do is to take our sulfur cathode technologies and some of the sodium anode technology we'll talk about later, and adapt those as materials. So we want to be a materials and licensing product. So my goal and that of my team from here now, our next goal is to get out and prove that we're important to the supply chain by putting in place collaborations in that supply chain. So a capital light business model is what we're adopting. You can see that we aim to produce materials. Even the production of those materials may be toll manufacturing to us. We aim to have the cells produced through collaboration with tier one manufacturers. And we indeed may be selling some of those cells, but they'll be manufactured by the manufacturers. So again, toll manufacturing for us. And then up at the top end of our business, keeping us in touch every day with the real world customers. We're developing our integration business, and a bit of a call out to Stu and Nick here, our team that's working on integration and opening those doors for us and cracking into those markets, doing an excellent job. So you'll see Gelion working on revenue and margin up in the top end, working on a capital light model to develop value as quickly as we can with our sulfur technologies. I'll now pass to Adrian.
Thank you, John. Now, as John just highlighted, Gelion is not a battery manufacturer. We are a materials manufacturer. And what you can see on the right-hand side of the slide here in the vial, the black powder is our product. So this is what we call a sulfur active material. And this is what we use to manufacture cathodes that are then integrated into your batteries. Now, there's a big USP for our cathode material, which is that it is very low cost. Why? Two reasons. Because we are using off-the-shelf standard equipment to manufacture it. And secondly, it uses sulfur, which is much cheaper than competing cathode technologies. And therefore, we've got really the opportunity here to have a very high margin product. Now, the product will be delivered to our customers, which will be cell manufacturers and battery manufacturers, in the form of a powder. And it is them who are going to process this powder and make it into a cathode. So what they're going to do is they're going to take the powder, they're going to mix it with a solvent, which can be water or off-the-shelf organic solvents already used lithium ion, some additives, binders, and make what we call a slurry. And this slurry will be cast onto what we call a current collector, which typically is aluminum foil. And when dried, this is what is called a cathode. And then the battery manufacturer will be able to cut this cathode and integrate it into any cell format moving forward. Now, the important point for our product is that it can be processed using existing lithium-ion cathode manufacturing capabilities. So it's very easy for our customers to adopt our chemistry. Now, this is supported by a very strong IP portfolio. We've got 229 patents across the sulfur battery value chain, on the sulfur and the cathode, of course, but also on other parts of the battery, on the anode, on the electrolyte, but importantly on the battery management system as well, which also underpins our battery integration business that John will talk you through later in this presentation. It took us a few years to put this really impressive IP portfolio together. It all started with the generation of a patent from our founder, Professor Thomas Maschmeyer at the University of Sydney. Then Gelion acquired in early 2023 the Johnson Matthey and Oxis Energy IP portfolio worth over £100 million of investments into R&D. Then Gelion acquired Oxlid, the company which I founded, which came alongside a very important license from the University of Oxford. And then finally, the last missing piece of the puzzle, the IP from the Max Planck Institute. Now, this represents a really comprehensive IP portfolio, which will allow us to partner with cell manufacturers so that they can integrate our sulfur technology into a range of battery chemistries to electrify a broad range of applications and stream. Now, Lewis, would you like to explain to the audience what the Max Planck Institute technology is about?
Yeah, sure. Thank you, Adrian. So these are the results on this plot that have us so excited. And I'm going to try to do my best to talk you through them so you can appreciate them and hopefully see the beauty in them that we at GELION see. So in order to understand this plot, there's a terminology which is useful to have in mind, to have a rough understanding of. And that's called the C rate. The C rate is a term that's used commonly in battery development to qualify or to determine the quality of a battery, specifically with relation to its power capability. What it essentially tells you is the rate at which you draw current out of a battery or put current into a battery. So if we start at the left-hand side of this plot, you'll see a term 0.1 C. That corresponds to a full discharge or a full charge of the battery over 10 hours. And this is a rate of use of current which is relevant to some aspects of stationary storage, but not much beyond that, right? And typically, sulfur batteries have kind of been stuck there, right? They couldn't really get much beyond 0.1 C. Now, you could get some going to 0.2 C as we walk over to the right, 0.5 C, but getting above 0.5 C was always a challenge. Now, with this technology that we have, you can see that even at 1 C, we're able to maintain pretty good capacity, and that's the distance we are from the horizontal axis, right? So we lose only a very small fraction of our capacity going from 0.1 C to 1 C. Now, 1 C corresponds to a full discharge or a full charge in 1 hour. And now you're talking about a power capability which is relevant to EVs and which is relevant to different aspects of stationary storage. So, for instance, backup power. So in an EV, if, for instance, you think you drive your EV, you're driving it for about on the order of a couple hours, 3 hours, 1 C corresponds to that rate. And it's really, really important that we can hit that rate if we want to target our batteries to that huge market. Now, even more impressive, we can keep walking to the right, beyond 1 C to 2 C to 5 C, even retaining pretty good capacity, 66% of capacity at 10 C. 10 C corresponds to a full discharge or a full charge in 1/10 of an hour or 6 minutes. So now we have power capabilities that align with the best power capabilities in LFP. This BYD Blade, which was released recently, which they've been talking about being able to charge in 6 minutes. Our technology is capable of that fast rate. So as that infrastructure comes online, we can use batteries made with this technology and we can charge them in 6 minutes. Also, for applications like drones, where you have a big power requirement in takeoff, vertical and vertical landing, this battery technology is able to handle that. So this plot shows very well how we're able to take those power capabilities, and I hope also we've been able to explain a little bit how those power capabilities translate to relevance to different markets. Now, in addition to power capabilities, as John said, Max Planck has shown that this technology is able to not just cycle at high power, but also cycle for strong cycle life. So they've shown that they can take this up to 1,000, 1,500 cycles, and they can do that at very, very good C rates. So 1 C or 2 C, not a low power, but actually a high power, and still retain good cycle life. So if you give me a click to the next slide, we can talk about how this fits in with products. So as Adrian and John said, we're not a battery manufacturer. We make a material. We make a cathode active material. And the benefit of this is that cathode active material can fit into our strategic partners, our corporate partners. It can fit into the different batteries that they make, right? So our powder fits into those pink tiles at the top. It's the cathode active material. It's the key component of those pink tiles. And nicely, we can match those pink tiles with the technologies of our partners, and we can access different battery types. So again, if we start on the left, we have what we call advanced lithium sulfur. This is a battery targeted to the drone market. You can take the 400 watt hours per kilogram that we've already achieved, and now with access to this Max Planck technology, we'll be able to take that to much, much higher cycle life and much higher power capability, and we'll be able to make successful drones with it. All the way on the right, you have the all-solid-state lithium sulfur battery. We've announced some results on solid state. We're going to apply the Max Planck material and perhaps combine that with the solid state material, and we'll make a good battery for EVs. And in the middle, we have the new technology which Max Planck has opened up to us, which is the sodium sulfur battery. Now, we're really excited about this because we told you about how cheap sulfur is and how abundant it is. Sodium is also similarly cheap and abundant. You probably have quite a bit of sodium on your kitchen table. So we can take those two elements, we can put them together, and we can make a sodium sulfur battery, which is going to be slightly less higher performance than the lithium sulfur battery, but it will be exceptionally cheap, and it will be a great battery for your stationary energy storage and your economy EV market. So if you give me one more click over, please. All right, so you can see we're excited about it. We're not the only ones. We were very grateful to be given a grant by the Australian government. This is a $5 million grant, which equates to roughly £2.5 million. It pays for half of a new £5 million or 10 million AUD facility that we're putting in Sydney. This facility is going to be dedicated to scaling up the Max Planck material, so we can make a lot of it, and we can get it out to those strategic partners, and we can get them on board and get the interest humming, and also to the adaptation of that technology to some more commercially relevant cell types. And the reason that we want to do that is we can then take those cell types and we can talk not just to materials partners, not just to cell manufacturing partners, but also crucially to offtake partners. For instance, Glencore, who are a partner we have, and who we would take these cells, send them the cells, and get them to have a look and hopefully drum up interest from an offtake partner. So with that, I'll hand back to John, and he can tell you about how the integration business fits in with all the technology we talked to you about just now.
Thank you, Louis. Okay, so the first part of this presentation, we're talking to you about GELION, the sulfur battery company. We anticipate building a lot of value in that side of our business. So we talked about the government grant, the 3-year grant, the ACPC. We talked about the 3-year collaboration with Max Planck. Talked about the activities that we're doing to develop our corporate strategic relationships. On the way from Australia, been through Japan, China, India, had a team in Korea as well. Those activities are very, very active right now. So we're having a lot of conversations, discussions. We'll talk about an MTA we've put in place as we progress the presentation. But there is another side of our business as well, and that's the integration solutions business. So this is where we're starting to develop revenue and margin. Now, this is using third-party cells. So the synergy between these two things, in the course of those visits to Asia, we were meeting with founders of the largest companies, or CEOs or CTOs, or their respective business line person in each case. And these are the leading companies. We are, through our sulfur work, able to command access and recognition, which is fairly serious. These are also the suppliers that make the cells that are utilized in ESS systems today, the leading suppliers. We see opportunity for synergy. The integration business can be fairly ordinary if you don't have a unique differentiation. We see that the relationships that we're establishing on the sulfur side of our business as being differentiation in what we're doing in integration solutions, making it possible for us to access the very best technologies and to access those technologies in a competitive way, and to turn that into revenue and margin for our shareholders. Very pleased with the work our team is doing. They're a great team. It's a small team at this stage, but they're making good progress. We're very happy with the progress. Particularly, we took on a project with Paul, and that project is going very well, progressing systematically, and it's leading to early revenue. So we've just recently announced that we'll be taking up £780,000, and our goal is to continue to grow this business. So we'll be investing in the development of this business alongside the development of our sulfur business. I'm very excited by that progression. Okay, I'm going to go to a snapshot of our financial performance, and for that I'll pass to Amit Gupta, our CFO.
So on this slide, we are presenting FY23 and FY24 results. FY24 is June 2024 year end. Why am I presenting this? Because we have presented these results before. It's purely for context. Unless I present the historical results, it's hard to appreciate what we are going to do for FY25. Over the last 3 years, we have continued to improve our financial performance, accessed non-dilutive government grants, improved our operationals, driving operational efficiencies, enhancing team performance, leading to cost savings of 1.6 million or 21% when you compare it to the FY23 levels. That is significant. We have to consider the cost savings and also consider the amount of work that's been undertaken by the team and the developments that we have made. Looking ahead to FY25, it's quite exciting, as John was talking about the integration business. That business is growing really well, and we have a very strong pipeline, and we hope to convert some of the pipeline customers into real customers shortly as well. What this slide shows is GELION remains focused on delivering innovation with discipline. In FY25, you see this massive revenue growth of 34%, 35%, primarily through the integration revenue generation, so £1 million. In terms of sequence of events, the containerized BESS has reached Australia. The plan is to get it delivered to the customer by mid next week when we recognize the 80% of revenue, and the remaining 20% in sometime mid-June when it's successfully commissioned. So this is what we said when we released the announcement in October, November last year, and we have delivered on those results as well. This revenue growth and the margin from this deal, combined with operational efficiencies, is obviously expected to deliver better financial outcomes. In FY24, our adjusted EBITDA loss was £4.8 million. In FY25, we are forecasting that to go down by another 10% to £4.3 million. That's a 10% improvement on FY24, but 28% improvement on FY23. I'd also like to highlight that this forecast adjusted EBITDA is approximately 16% lower than what the analyst forecast was when that was released in March early this year. Most importantly, we are now generating revenue and margins whilst we continue to advance our technology and gain industry validation. We are getting closer to commercial sustainability and long-term value creation for our shareholders. So we appreciate the patience that everyone has shown, but I'll pass it back to John for closing comments.
I have to give a call out here to Amit. Amit is tireless in his efforts and performing brilliantly, and has been a great partner as we've been working through the process of improving the quality of the business and reducing costs at the same time. I think we have in July one of the most amazing growth prospects in terms of growth and value and all the work that we're doing in our core technologies. And yet you can see from these graphs that we've really been disciplined in our management as we've done that. We've also significantly enhanced our team as we've gone along. Both Louis and Adrian have been additions as we've brought this on, and the Oxford team in the UK. So fantastic work across the team there. Okay, we have recently completed a capital raise, and we're very grateful to all the supporters who participated in that raise with us. It was oversubscribed in that we did raise approximately 2.6 million, which is subject to the general meeting, of course, in May. Strong participation from both existing and new investors, and we're very happy to achieve that in the current market that we're working in. The use of funds, we're going to be applying those funds diligently as we undertake with everything that we do. So we'll be applying those funds to building the value that's been unlocked by the combination of all of the platform of technology that we built up, the IP and the acquisitions, and then complemented by the Max Planck piece that we put in there. So very excited about doing that. There will be business development. We believe that we have something very important, a very important breakthrough for our industry that, for once we can see that sulfur can go beyond lithium-ion in many areas. And so we'll be letting the industry know that and establishing our position. My primary goal, and that which I'm leading our team towards, is to put in place corporate collaboration to build on the platform that we do. And while we're doing that, we'll be supporting our integration business to grow, and we'll utilize this also for working capital. So in summary, this is simply the most exciting time for Gelion since I've been CEO. We have now a very strong product market fit proposition. We have work to do, and that's why we put in place these term collaborations, the collaboration with Max Planck, the ACPC, and that's why we put in place supply chain collaboration. So there's work to do, but our lithium sulfur path has potential to be the super compelling product for high-end transportation. And our sodium sulfur, our room temperature sodium sulfur product, both building on the same sulfur cathode technology. Our sodium sulfur product quite simply can be one of the most important products in the whole energy storage industry. When you look for long duration energy storage, you look for being able to value stack applications in grid ancillary services, off-grid markets. The potential for room temperature sodium sulfur is absolutely enormous. So it is fundamentally now a turning point that we've been able to match technologies to enormous markets. We have strong intellectual property that we've assembled. We have signed an MTA, so the progression is generally NDA, then you move to an MTA. An MTA is a materials transfer agreement where basically manufacturers are testing your materials to validate the test results that you've got. Then you move from MTA and you work towards collaboration. So that's the systematic progression. And to have an MTA signed with a tier one battery manufacturer, and also to have strong collaboration engagements or discussions, whatever you want to call them, with multiple suppliers across the territories that I showed you earlier, has put us into a strong position. We're going to be working that really hard in the next few months. Major partnerships in development. We know where we want to go, the capital light model. We want to go on this path to maximize value for our shareholders, margin, while keeping demands on capital light. Got our early revenue going. Very proud of that group. Thank you guys for all the hard work you're doing. Good backing from the UK and Australian governments, and we're in a large and high growth market. So batteries is always risk, but on the other side, there's huge opportunity, and certainly we've been working very hard on risk mitigation and to maximise the scope of the opportunity for your company. Thank you for this opportunity to share this presentation with you, with my team. We have a lot of questions. I'll get into those as usual, and we'll try to progress through the questions as quickly as we can.
Fantastic, John, and the team. Thank you so much for your presentation. Ladies and gentlemen, do please continue to submit your questions just using the Q&A tab situated on the right-hand corner of the screen. Just while the team take a few moments to review those questions submitted today, I'd like to remind you that recording the presentation along with a copy of the slides and the published Q&A can be accessed via your investor dashboard. John, as you said, we've had a number of questions, both pre-submitting throughout today's presentation, and thank you for everyone for submitting those. Can I please ask you just to click on that Q&A tab, start at the top, just read out the question where appropriate to do so, and I'll pick up from you at the end.
Thank you. So in order, here we go. First question: does Gelion foresee any competition from graphene batteries? Not at the moment, but what I will say is the batteries technologies are introduced on a progression. The progression that I'm seeing at the moment, lithium ferrous phosphate, lithium manganese, nickel cobalt, they're the incumbents today. You're going to see high silicon start to come in the industry. You're going to start to see solid state come into the industry. And the one that I believe will follow that is sulfur-based cathode technology. So I think that we're on sort of a train with what we're doing with sulfur, and that all of these technologies are going to find their position. When do you expect income to flow, bottom line profit be seen? Income is flowing. That's happening through our integration business. I have not yet given you projection on when profit is going to be seen on the bottom line. The integration business has a lot of prospects. Let's travel that journey together as we progress, but we do have income flowing today and margin. Can you comment on the Naxtra sodium-ion battery? What a great announcement by CATL. What are they saying? Well, it's authenticating sodium-ion. Sodium-ion and lithium-ion. Lithium for high performance, sodium abundancy and low cost. Gelion, we've got sodium and lithium covered with our sulfur technologies. We see sulfur coming behind. So we see that as being very encouraging. Louis.
I can add something to that. So it is a very important announcement. So it's a very good high performance sodium ion battery. To the best of my knowledge, it is the first mass produced sodium ion battery. Things like this are incredibly encouraging for us because we're going to be able to take our sulfur cathode and replace the cathode that cattle currently use to make their Naxtra battery, right? And it means that all of the infrastructure required to actually do that mass production is already in place. So we just take our powder, put it in the right place, feed it through, and we make batteries that hopefully operate at least as well as the Naxtra battery. We can make them in mass production because the facilities are already there, and we do it with a cheaper, more sustainable, more abundant cathode active material, which is based on sulfur.
Beautiful. Thanks, Louis. The recycling project is promising. Hell yeah. Young Jake, who's leading that project, is doing a great job. How much competition exists? There's actually a lot. There's a lot of competition in recycling, but we have a good foundation of technology that we got from Johnson Matthey, and we have a great young leader who's working that really hard at the moment. So we're in there competing. It's been great progress over the last year, so congratulations to Gelion. Thank you. I have 3 questions. That's not too many. 1, does the MTA with the Tier 1 battery manufacturer include exclusivity clauses, or can Gelion work with others? This is a really good question. And at the moment, we are doing 2 things. One is we're developing relationships with manufacturers in the supply chains across those core geographies that I shared earlier. Now, that does give us geopolitical questions as well in the way that we approach it. I hope all of those geopolitics have settled down and we're able to utilize the best around the world for the purposes of the energy transition. But they are considerations. I think the big consideration that I'm going to be working through with my board is, should Gelion be aspiring to set up competitive tension between manufacturers as core partners, or should Gelion be aspiring to work across all the geographies? And that's something that I certainly will be taking up with Graham and Steve and all the rest of our directors as we progress. So it's not exclusive, and we will be looking at both sides of where we should be working exclusively or broadly. I recently read that the Smart Energy Council has signed an MOU with the government of Uttar Pradesh as Gelion as part of the efforts to forge closer ties. We're working really hard in India. We love working in India. We love working in all the areas that I've discussed, and we're working really hard to become part of that global community. What opportunities exist for Gelion in this country? Well, I think, look, talking specifically about India, what India wants most is India wants to develop to become a manufacturing peer to China. So China controls a lot of the technology at the moment and a lot of the production. India would aspire to be a major global supplier as well. And India would aspire to be able to have an independent supply chain. Now, I think that Gelion with sulfur can make batteries better in China. They can make batteries. We make batteries better in India. We make batteries better in Japan. We make batteries better in South Korea. We make batteries better in Europe and in the USA. So I'm hoping that sulfur ends up being that supply chain equalizer that really steps up the competition between nations in our industry. It certainly has the potential to do that, being a chemistry, sulfur and sodium, particularly being chemistries that could be manufactured from materials that are available anywhere. Finally, would it be worthwhile engaging in more media events outside the industry? We're trying. We're certainly stepping that up, and we agree with you. With having the compelling proposition that we have now, it's certainly a good time for us to be doing more. around letting people know.
John, do you mind if I add something on that question, if that's okay? So it's probably worth you all knowing that the business development in the background is incredibly strong. Some of the companies that John has been talking to are in the top 10 or 20 of lithium-ion battery manufacturers worldwide. So the significance of the business development, I would say, is very, very strong. And John's doing a fantastic job in that area.
Thank you, Graham. Working hard at it. Putting the big yards in with my team. All right. So the announcement, it's announced that the company signed a term at MTA. Which company is it with? When will we find out? Not yet. Sorry, I didn't want to be flippant on that one. We withheld the name for a number of reasons. What is the nature of the relationship and what is the capacity to earn revenue from it? So I showed you a graph earlier. I showed you a diagram earlier, and we had Max Planck, we had Thomas, and then we had a partner. We told you that we had the 3-year funding from the Australian government. What we want to do is want to click in collaboration partners. And the goal of that is to come out at the end of that cycle with full cells. So we would be providing the cathode active material, the sulfur material. They would be complementing what we're doing. So we anticipate our collaboration partners bringing technologies with them, like lithium metal technologies, lithium metal production technologies, pre-lithiation technologies, solid state technologies, and production technologies. Working together, we then resolve the full cells for production, and we take those cells out. So you're going to see the two parts of GELION growing very quickly. You'll see us grow. We want to be the leader globally. We want to be the company that really brings sulfur cathode materials and does the breakthrough worldwide. It's actually what Thomas tasked me when I first joined GELION with achieving dominance in an area of the battery technology industry, and now we have a chance to do that. Okay, why was the recent retail offer not available to Australian shareholders? Look, we try everything that we can to involve all of our shareholders. The process was resolved in the end that we had to do the book build in the UK. The Australian shareholders, we couldn't put on a separate exercise in Australia based on what was required at the time. It's no disrespect to any individual shareholder there. We love all our shareholders, but the company is listed on AIM, and we utilise the process to the shareholders' best interests. What is the pathway to the company scaling up production, manufacturing the battery material in order to supply it volume to battery manufacturers? What challenges, obstacles need to be met? Well, that's something I could spend an hour on, but what we need to do is be disciplined about ensuring that we meet all of the capabilities that are needed for a battery. I gave a presentation yesterday up at Cambridge, and it was called Where the Periodic Table Meets the Rubik's Cube. And the analogy of the Rubik's Cube is it's not enough to have a battery that can do high energy density alone. You must have a battery that does all of the characteristics, whether it's high energy density, power, or cold and hot temperatures, the whole package, and it must be able to be produced at scale. What I can tell you is that there are challenges in that, but I got the best in the world. I believe I've got access to the best in the world to do that, and the way that we're going to proceed against that is working with Max Planck on the material side, working with Thomas and team on the capabilities to scale that material, and then working with the tier one manufacturers to actually introduce it into cells. By breaking it down that way, by working with the best in each one of those segments, we can move quicker than if we were to try to do everything ourselves. When does GELION expect to break even? I sort of started answering that question. From revenue generation from supplying lithium sulfur, sodium sulfur to battery manufacturers, and the best business. It's very hard to predict directly the time frame that we'll be doing on. What we can say is that I believe that I'll answer it this way. Say what we're doing is already important to the end users. So we're able to demonstrate now to the guys that are making electric vehicles, that are making drones, that are making ESS, that sulfur is going to hit targets that are going to be important to them in definable timeframes. As we become important to those end customers, we become increasingly important to the supply chain, to the manufacturers that we're working on as well. I can tell you that in my meetings with the tier one manufacturers on my way up to London on this trip, I was surprised by how aggressive they were about how far they thought they could pull our program forward. So as we put those collaborations in place, I'm hoping that we can move quite quickly, but we're putting in place 3-year timeframes around the Max Planck. We're putting 3-year timeframes around our ACPC. I guess what the tier one manufacturers are saying is they can move us much faster than that. But that's to be seen.
Again, do you mind if I just add one thing, John? So becoming cash flow positive, you might think of that as being time-driven, but you also might think of it as being event-driven. And the event might be an investment from a major corporate partner. So could well be event-driven.
Graham, I think, if we were a private company today, our valuation would be, I don't know if I'm allowed to say that, would be significantly different. But I think that what the public market needs from us is external recognition of the importance of what we're doing.
Exactly.
And so when we recognise that importance by corporate strategic partners coming in, I think that's going to lead to a lot of value for our shareholders.
Yeah, totally agree.
I hope I'm allowed to say that. How do the batteries deal with heat and extreme cold, and how much heat does the sulfur technology create? Yeah, actually, this is a very important question. Yes, we're seeing that in our testing that we're able to deal both with heat and cold, and we're really pleased with that. What's the period of the MTA? When do you expect the announcements? That's in the control of our partners about the results. We'll be working along with them and setting in place the plan. But at the same time as we're working on the MTA, of course, we're working at putting in collaboration agreements in place. So that's part of our commercialization program, moving quick. Can the Max Planck, we were able to validate the Max Planck results reasonably quickly. That only took us in a matter of weeks and months. Can the Max Planck cathode technology, when integrated with Gelion's sulfur cathode, avoid the need to fabricate externally? We have huge aspirations for how much of this material is going to be fabricated. So we'll be developing the fabrication technologies internally. And then whether we form collaboration partnerships to toll manufacture the material or whether we manufacture the material ourselves, that will be commercial decisions taken by the board of directors that I'll consult when it comes to that time. But it'll be a case of how quick are we moving. I think then it's attractive at the moment to think about working with some of the largest manufacturers, and some of the supply chain development activities I've been doing with major corporates have actually been with material manufacturers as well as doing it with cell manufacturers. Under the how does the recent breakthroughs with sodium-ion batteries by CATL impact Gellion? We have sort of answered that already. Louis gave a great answer to that question. But bring on sodium. We believe sodium sulfur is the most abundant cell. Are you going to defend copycat pirate producers of your technology? Hell yeah. We will fight to make sure that we defend all of the rights that have been developed with the great assistance of our shareholders. When do you see sulfur being used in commercial batteries? Any thoughts on timelines for adoption? In the shortest term, there are paths to see early adoption of sulfur for applications like drones. To actually make those applications real, you needed breakthroughs in power. We see a path to those breakthroughs in power at the moment. So you can see reasonably early opportunities for revenue down that path with the new breakthrough capabilities we've got in the chemistry. And then you're going to see progressive integration of the sulfur into different applications. What I am prepared to say now is I'm very, very, very confident that sulfur will be one of the most important breakthroughs in the battery industry. That's what I've been committing myself to. And secondly, that when it does, that Gelion will be amongst the leaders at that point in time. So that will bring value through to our shareholders. Under the MTA, can you comment on risk with the energy costs associated with producing the cathode raw material in Australia? Yeah, look, that's not a real problem. I'll finish this as the last question. So I'll finish it in a particular way for you. The technology that we're utilizing works in a particular way. It uses low-cost materials, and we actually formulate the cathode material using a straightforward and commercial method that can be developed using existing production techniques. The particular breakthrough works to constrain the sulfur in a way that firstly controls that only the sodium and lithium can get to it. That stops certain side reactions from going on that would degrade the technology. And also it controls the reactions that the sulfur can do. So it redefines sulfur technology. That's what the industry's been looking for. Very happy that Gelion has been able to move so quickly. I mean, it sounds like a long time, but in the last sort of 2.5 years, to be able to get the Max Planck, to get the original Oxis technology, to be able to bring Adrian and the team from Oxford on board, to be able to put the Max Planck agreement in place, and now to be able to go out with something that is truly globally important and to target corporate relationships. We've been moving very quickly as a battery technology company. So this is the important time for us. I do want to say again, thank you to all of the investors that came in to this round. Thank you for all of our existing investors for your support. And welcome to any of you that are listening to Gelion for the first time or have listened a few times and have decided that this could be the key time to enter our company. It's an exciting journey. And thank you.
Fantastic, John. Thank you very much indeed for wrapping up there and updating investors today. Can I please ask investors not to close the session, as you'll now be automatically redirected to provide your feedback in order that your views and expectations can be better understood by the team. It's only take a few moments to complete, and I know it's greatly valued by the company. On behalf of the management team, GELION PLC, we'd like to thank you for attending today's presentation. That concludes today's session, and good morning.